Everybody, welcome back to another fun and exciting geometry class. Today, I'm excited because this is going to be one of my favorite lessons. I like this for a couple different reasons. One, because I like the content of this lesson. And then secondly, I like it because we're kind of transitioning away from a lot of the basic things that we were doing in geometry, where we were just kind of talking about things like terms and yeah, just kind of the more basic things where we're just kind of putting our foundation underneath of us. Now we're going to start doing some more what's called application of geometry. We're going to be doing questions and exercises that you might find kind of in real life. And I just think it has a little bit more life to it. So hopefully you are ready for that. You're ready to kind of change gears just a little bit. Now we're going to be doing the other stuff still. We have to use that foundation that we set, but it's a little bit different in the second half of the year. So 3.29 is where we're going to be. 3.29. That's on page 173. Page 173. If you look down here at the screen, we're going to be talking about the location of points. Locus. Locus. And I've already kind of touched on this because the concept already came up a few lessons ago, and we talked about the word locus, and I said we're going to be teaching a whole section on that in a little bit. So what is the locus? What's the loci? All right, so this is not Loki. All right, this is not Loki. Loki is from the Marvel superhero movies. All right, so that's Loki. All right, this lesson is loci. Okay, loci. That's a Latin word right there for more than one locus. Remember when we talked about the word radius? All right, radii is when you have more than one. And so here's another one of those words. So locus, and so locus, and then the plural is loci. This guy right here, Loki, is somebody totally different. So don't worry about Loki. We're talking about locus and loci. Okay, so what is the location of points? The loci. Okay, it's the collection of all the points that meet a specific set of given conditions. So the problem, the given, will give you some information, and it'll say something like all points 5 inches from the line, for example. It will say all points 3 meters from this given point. And it just gives you a set of instructions, a set of, if you will, conditions that it must meet that condition in order to be part of this set, this collection of points called the loci. Okay, we need to look at two, what we call here, what the book calls essential characteristics of a locus point. So what are the two essential? That means that they must be part of it in order to be considered a locus point. The first one is its exclusiveness. Exclusive. When something is exclusive, that means it excludes. Okay, Mr. Steve, you can't use the definition in the word. You know that, right? Yes, I know that. Okay, so let me give you an example. If something is exclusive, that means that certain people or certain things can't go into that collection. I think of like a fancy neighborhood or a fancy golf club or a fancy activity where it's by invitation only. What are they doing? They're keeping out the little people, right? Like me, I can't go to those things. Okay, I never fit into that group. I'm sorry, maybe you don't either. And so I am, or we are, excluded from that group of people. They want to keep their group small. They want to make sure that everybody in their group has the right manners. They want to make sure that they have control over their group. So they exclude certain people. Now, the other thing to think about is its inclusiveness. Okay, so what does this mean? If exclusive means it excludes or it keeps people out, then inclusive means it includes or it draws people in, like you're in the group. So if you're included in the group, which I never am, but let's say that I was, I'm now included in the group. Well, that means I'm part of the group. I can come to their golf club, or I can go to their dinner, or I can go to their house, whatever it is. Maybe they live in a gated community and I can't go in there because I'm not included. I need to get an invitation, right? In. It keeps using that word in. So you're inside. If you get an invitation, then you are included in the group and you get to go to this party. Well, it's the same idea here. Um, let's take for example, we have a line here, and I have a point A, which is the beginning of the line, and a point B, which is the end of the line. So here is the inclusiveness. Let's include all the points that are the same distance from A and B. Every point that is equal distant. So if I start drawing points here that are equal distant, you're going to see what ends up happening. I'm going to draw a perpendicular bisector, and I keep adding points. And this is where the confusion of some students comes in right here. And they think that a loci is just points. Well, if they keep going, and if you keep going and you keep going and you keep adding points, well, pretty soon, what do you get? You get something if you keep adding points to this. What you end up with is you end up with a line, okay? Now, it's kind of an ugly line, but, you know, I'm doing my best here with what I've got to work with. So there we go. It's a line. Every one of those points, I'll go back to this, every one of those points is the same distance from A to B. If you measure those, it's the same distance. And we've talked about this. This is where we talked about location before when we were talking about isosceles triangles and perpendicular bisectors, okay? And so if we keep doing this, we're going to have the same size line. So this line is 7 and 7. This line is 5 and 5. This line is 3 and 3, whatever it is, okay? They're both going to be the same. They're the same distance. Well, when you keep doing that, what ends up happening is you get a loci. Each point, each locus point creates, this is the loci. The loci is this collection of points right here that forms a line. In this case, it forms a line. Not always does it form a line. Sometimes it forms other things. Okay, so that's the inclusive. They were all included. Now, let's talk about the exclusive. That point right there. Well, if we draw our line to that point right there, well, this one is 9 and this one is 3. It's not included. What is the condition? The condition is that that has to equal that. It has to be the same distance. So this point is excluded. He can't come to the party. Why not? Because he's not invited. Why not? Because he doesn't meet the conditions that the given lays out. The given says, hey, you got to be the same distance away from the 2 points. And buddy, you're not, so you can't come to the party. Sorry, you don't have an invitation. Okay, so that's the inclusiveness of the line. Now, let's go down here and let's look at a couple different things. And this is on page number 174. This is actually lesson 3.30. Steps to determine or prove a locus. Step number 1. Prove that every point on the assumed locus satisfies the given condition. How are we going to do that? How are we going to prove that? Well, we have a whole book full, right? We have a whole book full of theorems, corollaries, axioms. That's where we're going to draw from. Remember, I told you we have to use the stuff that we've already covered in this, but now these problems are getting a little bit different. So you have to use those things that we've already covered. So go back and use your book and you figure out what of these things that I've already learned, what proves that all of those points. And we have a theorem, don't we? We have a theorem that proves that every point on that straight line, the perpendicular bisector, is equal to the endpoints of that line. We have a theorem that says that. So we would use our theorem to prove that. So that's the first thing that we have to do, is we have to prove that every single point on that assumed, and I put that in quotation marks, And there's certain reason why I put that in quotation marks. And if you've been in my class before, you know why I put that in quotation marks, because it's always trouble when we start to assume things. All right, I'll just leave it at that. And so the assumed line is the one that we're kind of saying, oh, we think this is true. Well, but then we have to prove our assumption that that actually is true. And so that's point number one. Point number two, the second thing we need to do is we need to prove that every point that satisfies the given condition is on the assumed locus. So let's go back and look at the difference. Those are kind of really close. Number one, prove that every point on the assumed locus satisfies. Prove every point that satisfies. So now we go back and we look at the satisfies sign. Okay, now we say, does that satisfy? Let's go back up to this point right here. I've got a problem with this location. I did this on purpose. And some of you are thinking, yeah, you got every point. Every point that satisfies that is on that line. Well, it's true and it's not true, because I did not include the points that come down here, because these points also satisfy our condition. What's our condition? That they're the same distance, 7 and 7. There we go again. Now we have the same points. So all of these lines now going down are also part of our condition. So what I did on purpose was I satisfied the first part, prove that every point on the assumed locus. I assumed a locus, okay? So this was my assumed locus up here. And I said, yep, every point on that is indeed it meets the conditions. Good. But then I never went back to the conditions and said, is this all? Are there any more that might support the given conditions? And that when I went back to look at that, I said, oh yeah, I forgot. There's some that go down too. And so really this would be a line that continues that way, and this would be a line that continues that way all the way, indefinitely. Okay, never stops. So we'd have to put an arrow on those loci in order to show that they go in both directions infinitely. Okay? Look here. It says, when taken alone, step number 1 does not prove that there could be other points. That's what I did. I took step number 1 alone. My problem was I did not take into account that there might be other points that actually satisfy that too. Okay? Then if you do step number 2 without step number 1, it does not consider the possibility that certain points on the locus do not meet the condition. Now, we haven't had that one yet, and we'll get to that a little bit later as we keep going through this section. But now what it's saying is that, well, maybe, I don't know, maybe there's part of the condition that would rule out that point right there that's on the line. Maybe the condition actually says all the points off the line. Okay, let's say that. All the points off the line. Because there is a point right here that's on the line that meets the condition. Unless it says all the points off the line. Well, now that does not meet the condition. So it would be all of these points except for excluded that point that's on the line. Why? Because it says that the points have to be off the line. Okay? So there's certain times where you're going to get some exclusions within the given information, where it tells you that it can be or it can't be on the line. It can be, in the triangle. It can't be in the triangle, something like that. I mean, think of this. If we have a triangle and it says the locus of points in the triangle, well, now we're talking about these points right here. And we're not talking about these points right here because they're outside of the triangle, okay? We're only talking about that line right there. We're not talking about the ones outside. So there's sometimes that they give us multiple conditions, and we had to work through all of those different conditions to find out where we're at, okay? All right, well, that's all I have for you for this lesson. Thanks for paying attention. If you missed anything, make sure you slide it back and take a look at it so that you can get these right on your quizzes and tests coming up, okay? All right, we'll see you later. Bye-bye.